Hello, this is Catherine Koch. Welcome to my poster on the effects of muscle fatigue on EMG amplitude. The purpose of this study was to find out if the amplitude of an EMG signal changes when a muscle fatigues during isometric contraction for an extended period of time. I hypothesized that as muscle fatigue increased, EMG amplitude would also increase. Literature shows that when a muscle fatigues, the motor unit action potentials increase, which is shown on an EMG as an increase in amplitude. Motor units are made up of different types of muscle fibers categorized as fast twitch and slow twitch, which are differentiated by their characteristics. This study included 8 subjects aged 22 to 26 years. Please refer to the subject section for more information. The study was performed by placing 2 pairs of electrodes on the wrist flexor and extensor muscles on the subject's dominant arm while they had a dynamometer in their dominant hand. Another pair of electrodes was placed on the tricep muscle for grounding purposes. A grip test was performed to find the subject's maximal voluntary contraction force, and 25% of that value was calculated. The subject then held the dynamometer at this smaller force for as long as possible, up to 300 seconds, with peak EMG amplitude and force values recorded every 15 seconds. Later, the mean and standard deviation were calculated for all 8 subjects' force production and EMG data. These values were entered into a table and then into the 2 graphs in the results section. In Figure 1, time is plotted against force as the purple line. The mean force production, which was supposed to remain constant, did not vary much over time. In Figure 2, the blue plot represents the flexor data and the green plot represents the extensor data, which are on the y-axis, with time on the x-axis. These plots had large standard deviations, showing that there were discrepancies in the data. The 2 black lines are trend lines for each set of data, both with a negative slope, showing that the mean muscle activation decreased over time for both muscle groups. These results did not support the hypothesis. Instead, as time and fatigue increased, the amplitude decreased. This discrepancy may be partially due to fast twitch muscle fibers being recruited and fatiguing quickly, after slow twitch fibers that were recruited in the beginning fatigued over time. However, this discrepancy in the study was likely caused by human errors and flawed methodology. Looking closely at the data, 2 subjects had abnormal values for EMG muscle data throughout the test. This was likely due to human error. These values skewed the data, and the results may have been different if these values were excluded. Additionally, having 8 different groups perform the study is a cause for error because each subject was prepped and tested differently, causing additional discrepancies. Thus, more research should be done to truly support or reject this hypothesis. The clinical relevance of these results is that fatigue may not be fully represented in EMG data, so patient subjective and other objective measures should also be used to determine fatigue. Thank you for listening.